Hi guys, in this video we'll go over latches. Okay, so first of all let's go over the NOR latch and then I'll explain the NAND and D latch. Okay, so for the NOR latch, so you have like two inputs, okay, and you have a NOR gate, of course, because it's a NOR latch, okay, and then you have an output of this one, okay, and then you have another NOR gate, okay, and then the output of this one is going to be connected to the input of this one, okay, and then the output of this one is going to be connected to the input of the second one. Okay, so that's basically what a latch is. Okay, so you call this an SR latch, and it's going to store the computer's memory. Okay, this is how the computer stores the memory, and the latch stores like 1 bit of data, and the cross striping that you see, this provides the memory. Okay, and if you like want to predict the inputs, like the outputs, okay, so like for example, if I go ahead and put a 1 over here, so and then the input of this one I put a 0, so can you predict the outputs? Okay, so let's go ahead and label these. So S, R, Q, Q prime. Okay, so now if I provide the input as 1 over here, how can you determine the output over here? So for this you'll have to make a truth table for the NOR gate. Okay, so let's say first of all let's make for the OR gate, so it's easier for you guys. Okay, so if we are doing for the OR gate, you already know as long as we have a 1, we put a 1, right, and the rest is 0. Okay, but if we're doing for the NOR gate, so what do? As long as we have a 1, so we're just going to inverse it, right? So as long as we have a 1, we're going to put what? A 0, right? So 0, 0, 0, and for the rest we put 1. So that's our gate. That's our truth table. Okay, so now if the first input is 1, you know as long as you have 1, you're gonna have what? The output, it's gonna be 0. Okay, so now since this is 0 and here this one is 0, and you know if you have the 0 output, so that's simply gonna be 1, right? Why is it 1? Because you had a 0 input over here, and you see the output of this one is connected to the input of this one, right? So the input of this one is 0 as well, so you have basically like a 0, 0 here, so that's why you're getting a 1. Okay, so that's your output. Every time you have like 1, 0, so the input is gonna be 1, and the complement of this one, it's gonna be 0. Now if I change the input and if I make the first one 0 as well, okay, in that case your output, it's going to remain the same. Okay, and this is what you call the hold state. Okay, because it's going to hold the state that it was previously in, because here you have like 0, and here you don't know the output of this one, right? Because the output of this one is going to be the input of this one, and here again like it's 0, and this one you don't know, right? Because it's just gonna be holding the previous state, because if it was not, then how would you determine it? Like, I don't know if it's making sense, but it's like it's 0, right? Okay, and you need to know the output of this one. Let's just say we don't know these. Okay, so so in that case we know this is 0, and what is this one? This is gonna be output of this one, right? If this is 0, so do you know the output of this one? Because to know the output of this one, you need to know the input of this one as well, right? And you cannot know if it's 0, you don't know if it's a 1 or a 0, because it can be like 0, 1, then it's 0. If it's 0, 0, then it's 1, right? You don't know that, because if it was a 1, then clearly we know that it's a 0, but if it's 0, it's hard to know unless we know the output. So that's why we're going to hold the state whatever it was previously in. Okay, so we had previously 0, 1, so it's gonna stay in that state, I mean. Okay, now if we go ahead and change this one to 1, okay, so if we're changing this one to 1, So like I said before, so if we have a 1, it automatically goes to 0, right? And now since you know the output of this one is 0, and now you have 0 0, so 0 0, that's a 1. Okay, so before, when we had like 1 0, so when we had like 0 0, the output was 0 1, and now we have 0 1 and the output is 1 0, so it's simply going to swap the result. Okay, and what about if we make the what about if we make both of them equal to 1? So in that case, it is going to give you an invalid state. Okay, so when you put both of them equals to 1, so in that case you're gonna get an invalid state. Okay, invalid state. So it's just gonna be an invalid state because the circuit is going to begin to oscillate. Okay, and it's gonna be unstable, so that's why it's called an invalid state. But like if you try to follow with the truth table as well, for example, like here, if it's a 1, so that's gonna give you a 0, and it's gonna give you 0, but it doesn't make sense, right? Because q and q prime, so q prime has to be like the inverse of q, right? But it's giving the same thing, so it doesn't make sense. So that's why the result is invalid, so we call it invalid state. Okay, so if you go ahead and make the SR latch truth table, so this is how it's gonna look like. Let me show you. So if you want, you can simply memorize the truth table. It's gonna be useful for the exam, but if you want, you can like know the concept. Okay, so we have 0 0 1 1, and here we have 0 1 0 1. So I have already explained all the possibilities. I'm just going to make the truth table over here. So like I said, if we make both of them 0 0, what do we get? We get the whole state, right? And if we make one of them 0 and other one 1, so we get 0 1. Okay, and if we make 1 0, we get 1 0. Okay, and if we make both of them equals to 1, what do we get? We get an invalid state. Okay, so that's the truth table for the NOR latch. Let's move on to NAND latch now. Okay, for the NAND latch, this is how it's gonna look like, and the concept is the same. We just replace the OR gate with the NAND gate. Okay, now, and the output is connected to the input and the output is connected to the input, so the concept is pretty much the same. So now we can go ahead and make the truth table for the let's go ahead and make for the AND first. Okay, A, B, and F, 0 0 1 1 0 1 0 1. Okay, for the AND, you know, as long as it's both of them it's 1, so it's 1, the rest of them is 0. Okay, but if we are putting a NAND, so it basically flips the output, right? So that means every time we have both of them equals to 1, so that is gonna be 0, right? So that is gonna be 0, and the rest of them it's gonna be 1 1 1. Okay, so now so you know, in this case, as long as you have a 0, you're gonna have a 1, right? So here you have a 0, so what do you have? You have a 1, right? And now since both of them is equals to 1, what do we have? We have a 0, right? So if you want, you can do this concept, the NAND latch, the truth table, but there's an easier way. You know, the output of the NAND latch, like the truth table, it's simply gonna be the complement of this one, the NOR latch. So you see, when we put the input as 0 1, what do we get? We got 1 0, right? So here we have like 0 1, we got 0 1, but we're simply going to inverse the result, 1 0. Okay, so if you want to do the truth table for the NAND latch, so this is for the NOR latch, and this is for the NAND latch. So you have SR. Okay, so you're simply taking the complement of this one. Okay, SR Q prime, and then you're going to write the same thing, 0 1 0 1. and then here since every time you have like 0 0, it's a hold state, right? So you're going to inverse it. So the inverse of hold state, it's gonna be invalid state. And here when we have 1 1, we had an invalid state, so that it's gonna become an hold state. And we had 0 1 over here, so that means here we're gonna have 1 0. And we had 1 0 over here, so that means we're gonna have 0 1. Add that, and this pretty much completes your NAND SOR latch. Oh, okay. So if you want, you can go ahead and verify your outputs for the truth table, but it's really easy to simply memorize the NOR latch table, and you can take the complement of this one to achieve the NAND latch table. Okay, so let's move on to D latch now. And yeah, before we go on to D latch, let me just quickly show you guys what we did in the lab. So this is what we did in the lab. So basically, like, you know, you have like an input and output. So for the latch, so you're basically connecting like the input of this one to the output of this one, right? And then the output of this one would be connected to the input of this one, right? So this is what you're basically doing when you're creating the latch. So yeah, it's gonna make more sense when you go ahead and actually do the lab. So good luck with that. So let us move on to the D latch now. Okay, for the D latch, it's pretty much simple. So all you have to do is just memorize the truth table. So every time like you have the enabler set to 1, so every time you have enabler set to 1, the output is going to depend on whatever the D input is. Okay, so if it's equals to 1 and this is equals to 0, okay, so enabler, it's going to depend on the D input. So if it's 0, so that's a 0. Okay, this is the output, and this is simply the complement of this one. So the complement of this one, what is it? It's 1, right? Like you're simply inversing it. Okay, and now if it's 1 again, so then if the input is 1, if the enabler is 1 and the D input is 1, so since it's depends on the output of this one, right? So if this is 1, so this one is 1 as well, right? And then the complement is 0. And then if we don't know the output of this one, and this is 0, okay, so since it's 0, so it's gonna hold the state in whatever it was previously in. Okay, so this might not make sense right now, and I'm gonna do timing diagrams in the next part, so it's gonna make more sense. So you can check out the video for the next part for the timing diagram. Okay, bye.